Hi everyone, I'm Maddie Horn, and today on Science Pickle we'll be talking about the Rainshadow Effect. This basically explains why there are usually two different climate types on either side of most mountain ranges. On one side, there's normally some kind of rainy, forested climate, whereas on the other side, there's an arid and desert-like climate. So, here we have a mountain range. The prevailing wind direction, the direction in which the wind normally blows, is moving across the mountain range. However, the actual compass direction depends on your latitude. In the tropics of both hemispheres, the surface winds tend to move from east to west. In the mid-latitudes, the winds tend to move from west to east, and they reverse again in the polar regions, moving east to west. Let's take a look at a parcel of air that's moving with the wind. So as it's moving in the prevailing wind direction, it will move up and over the mountain range. Let's say that the parcel's starting temperature, which is just the temperature of the air at ground level before the parcel moves over the mountains, is 80 degrees Fahrenheit, and its starting dew point, the temperature at which the water vapor inside the air will begin to condense into liquid water droplets, is 60 degrees Fahrenheit. As the air parcel moves towards the mountains, it gets pushed up along the mountain face. Since the air pressure decreases with altitude, the air parcel begins to expand and subsequently cool as it rises. Just as the parcel's temperature decreases as it climbs higher into the atmosphere, so will its dew point, but not quite as drastically as temperature. When the parcel reaches the altitude of around 4,500 feet, or 1,384 meters, its temperature and dew point are equal, and the water vapor within it begins to condense and clouds begin to form. More and more water condenses, and as the parcel keeps rising, precipitation begins to fall out of the cloud, so we'll get rainfall at the base of the mountains on the windward side. As all of this water vapor is condensing, that phase change from gas to liquid releases latent heat, which warms the air parcel even further as it crosses over the mountain peak and starts to descend on the other side. As the air parcel begins to sink back towards the ground, it gets warmer, since the parcel contracts as air pressure rises. However, it doesn't simply return to its starting temperature and humidity values. Since the parcel lost so much of its water content through precipitation on the other side of the mountain, it's much drier than it was before, say a dew point of 30 degrees Fahrenheit instead of its original 60 degrees Fahrenheit. And since that process released a large amount of latent heat, which warmed the air, it reaches the ground far warmer than when it started, say 90 to 95 degrees Fahrenheit instead of its original 80 degrees Fahrenheit. This steady supply of hot and dry air means that the regions on the leeward, opposite of windward, side of the mountain range have a consistently arid and desert-like climate, while the continuous precipitation on the windward side of the mountain range ensures a rainy and vegetation-rich environment. So that's how the Rainshadow Effect creates two different climates. I hope you all enjoyed the video and learned something new. See you next time!